Hello everyone, welcome to LeetCode Solver, and today we are going to solve 15, 16, 17th problem in May LeetCoding Challenge, and the problem name is find all anagrams in a string. Let me open the problem. Given a string S and non-empty string P, find all the start indices of P's anagrams in S. Okay. A string consists of lowercase English letters only, and the length of both string S and P will not be larger than 20,100. The order of the output doesn't matter. Okay. This ABC. Well, ABC anagrams. This is a anagram, so this should be included as 0 from 0 index. CBA is anagram of ABC. So anagram is basically the frequency of every characters in the particular. Both of them should be equal. So starting from 6, let's see 0, 1, 2, 3, 4, 5, 6. BAC is also a anagram of ABC. Well, sounds good. And for AB one, BA another one, AB another one, 0, 1, 2. Okay, sounds good. So as the length of the P is always fixed, P length suppose M, and we need to keep track of the frequency of every characters in P length, and say we somehow keep track of that. And the basic, I mean, the brute force solution will be just looking into every substring of M length, P length, and just keeping the just evaluating the frequency of the characters in that particular substring and the frequency of characters in P. So if we found that frequency is same, then we can just tell that both of them, the index starting from that particular substring is I mean anagram. So we can include in our answer vector. Well, this will take like how much it will take. Finding every substring of s length, we will just I mean iterate for every length in I, which is say s as n length. Then for every n, for every position in s, which is like every position is n positions, we will just iterate m times, and we will calculate their frequency. We will use kind of memory to maintain their frequency, and after maintaining the frequency, if we optimize it, then we can tell them in uh, like constantly. So we can say if we have like kind of complexity of m cross n cross m, then we can achieve that brute force solution by using extra space of 26 character. Well, let's think about a better solution. Another solution will be like from like if I maintain starting from every like ending at every index, like I have a total frequency of character till this point, like starting from 0 index till this point, the frequency of a is 2, and till this point frequency of a is 2, till this point frequency of a is 1. So in this way I can keep track of frequency of every characters till ith point. So if I maintain that, then in order to find the um, frequency of characters in range, I mean I to j, so definitely j minus I will be always equals to m, and in order to get that frequency of value in that range, we can simply get it from our pre-calculated array, which is maintaining the prefix frequency of every character. Then we can get it in um, constantly every time. So the complexity of solution will be big of n, and in this case we are maintaining extra space, like we are doing pre-calculations. So while doing pre-calculation, we need a another extra loop, which is n into 26. The complexity of the solution will be 26 times n. So it is a little bit, I mean, it is lesser than n times n, but it's still bigger. So what we can do instead is, instead of pre-calculating every frequency, we can just uh, maintain a lookup table which will hold the frequency of every characters. Say we have a frequency of ABC. In first example, frequency of A is 1. We have these things in our lookup table. B is 1 and C is 1. So say for example, if it is not 1, like if it is different, then what we will do? If it is like 2, if it is like 5, if it is 1, say, then we have something like this as a P. So we converted our P into a lookup table containing a character with their amount of frequency. Then whenever we access our string S, then up to 0 position to I minus m minus 1 position, we are fine. We will just put the frequency of every characters in this range. Then whenever we reach, I mean, starting from m minus 1 position, we will start calculating our answer. And every time whenever our index is greater than m, then what we have to do is we have just particularly remove this range and make it 1 to m. So this is our another valid substring. So another time we will remove 1 and make it like 2 to m plus 1. These are all valid we are interested in. Now we are just in order to get our interested or exactly m length substring, we just have to do a simple thing, which is just basically removing previous range. Like initially it was 0 to m minus 1, and every time we introduce new character, we will be removing its starting character. So the range is still of size m. So while doing these things, like while inserting the character, we will just simply add the frequency of the character. But while removing the things, like we are removing zeroth index, then we have to decrease the frequency of the characters. So this is our reference from which we will know for each character how much frequency we need. In addition to reference array, reference map, uh, we will maintain another frequency map, say, which will also hold the frequency of every character. Say if it is a1, then we are not still um, we are still need another character to count 1. So if it becomes like this, then we will increase our counter, say, and our counter is matched with this. And whenever we matched with counter and our counter value is equals to the total number of elements in this P, total entry in this P, I mean total frequency distinct characters in P, then we will definitely increase our answer. If our size, our size, frequency size, every character is matched with their particular frequency, then we will be increasing our this counter. And if somehow counter is equals to this to the size of this map, then we will be interested in that particular range, and we will be inserting the starting position of the substring. Let's begin programming then, coding. So let's define n as the size of s size, and let's define m as the size of p. And if somehow one of them is not available, we will simply return empty vector. Otherwise, let's define a vector as the answer, And what we will do, we will put all the characters in P to our lookup table. So let's create a lookup table, say hash map, another map of 50 characters will hold frequency, say hash map, and hash map of every character, say p of I will be increased by 1, and we find total number of characters, say total characters is equal to hash map dot size. We know total number of characters. Now we need to match our counter with total number of characters. So counter, say frequency counter, or maybe match counter. Match counter is initially 0, and every time we will iterate over our s and maintaining the range. Say if I is greater than or equals to m, in that case we have two operations, like we have to delete I minus mth character, and then after we have to insert, every time we have to insert ith character. While doing insertion and deletion, we will be maintaining the frequency related stuffs. So let's design our hash map, another hash map which will holding current frequency. So on our map, say character int current frequency, or prefix frequency maybe. No, we will be removing some character. So substring frequency it can be, or say current frequency, or say simply frequency. Will be maintaining frequency of characters. Well, insertion is simple. Let's frequency of say let's define a character ch equals s of I. Will be increasing ch frequency of character by 1. Now when we will increase match counter, so while doing increasing frequency, if we found that frequency, say frequency is big name freq, but maybe in coding interview we can just tell the interviewer that in production code we will be using some good naming, but because of the time constraint we can use simple name like freq. So if I say frequency of ch is equals to our lookup table's frequency, if it is matched with that frequency, then it's good moment. We will increase our match match counter by 1. But if we, by doing so, if we found that its frequency is increased to 1 plus hash map, it is greater. Previously it was matched, but now it is greater, then we have to unmatch. So match counter is decreases. So in insertion we have always increasing frequency. So by looking at this, we can just if it is like, say for example, we are trying to match two characters, and now we see that in our frequency map we see its frequency becomes 3 by inserting new characters. By inserting new character it becomes 3. That means for a it doesn't satisfy the counting, so we just decreases the counter. And in somehow like edge the deletion operation, somehow we decrease the edge frequency from 3 to 2, then we have to increase our counter again. So that was the case which will occur here if the I is greater than equals m. Now we have to delete I minus mth character. So let's delete it. Frequency of um, I minus 1 character s. Say let's define a character s of I minus m. CHR is decreases, and if we found that frequency of CHR by decreasing this, if we match with the required one hash map of CHR, if we match with a required one, then definitely we will increase our match counter plus plus. And by decreasing this, if the current frequency was matched before, now it decreases by 1 somehow. In that case, we have to decrease our match counter. So FRQ Q of CHR is equals to hash map of CHR minus 1. If it becomes minus 1, then I have to decrease the frequency match counter by 1. So previously it was 2, and by doing this subtraction or deletion operation, we see that now it becomes frequency becomes 1. Then it was matched before, so I have to unmatch this like by decreasing match counter. So yeah, I decreases match counter, and then after I increases, and by doing these things operations at some point of time, any point of time, if I found that my match counter TCH counter is equals to say total characters, then I will increase, I mean I will push the answer into push back into vector, so which is equal to I minus m plus 1 to be exact, starting frequency, starting index. And definitely by pigeonhole principle, we see that if I mean we will not having this condition if we do not have like the total frequency or total length which is equal to m by pigeonhole principle, as well as like if somehow in our new frequency we added some value like say d with the frequency like 1, definitely it will block other to satisfy like other character to have the, there won't be any situation like the all the characters in hash map are satisfied, as well as we have extra other values in our current frequency map, which will violate the pigeonhole principle, because the current the size of our map is always we are maintaining the size of frequency map is always equals to our m length. So that's why, well, finally we have to return answer. Let's return answer, and let's compile the code to see if there is any compilation error or what. Sounds good. Say a c 2 1 2 3 1 1 this 2 this, yeah, 3, yeah, all right. Let's submit. Okay, all right, accepted. Nice. So the complexity is as I mentioned before, complexity is big O of n, where n is the size of S. So as we can see, we iterate over m first times, and m will be, I mean, definitely less than m. Otherwise, like, we can also return such condition, like if m is greater than n, then we will return empty. So like we will not be iterating over bigger m. So yeah, the complexity is big over n because the m is less than n. Otherwise, we are returning empty vector, and we are iterating over every characters uh, over n times. And the operation we are doing over here is constant operation, just if else condition. We are not iterating, we are just performing constant operation. And the frequency, addition, insertion, and deletion, this operation happens in another map in constant complexity. So yeah, we got our time complexity as big of n, and space complexity will be the total number of character will be holding in S map, which is 26, as mentioned in the problem statement, all the lowercase English letters. So let's submit. There is something we changed just now. Okay, accepted. Yeah, thank you so much for watching this video. Hope you like it, and please feel free to subscribe the channel, or if you have any alternative solution or anything else to comment, please feel free to comment. Thank you so much. See you in the next video.